Hello everyone, this is Jeremy Eason and this is my database presentation. So we're going to start off with giving you guys a little bit of overview about databases. A database is an organized collection of structured information or data, typically stored electronically in a computer system. Modern databases are managed by database management systems like PostgreSQL, which provides tools for data storage, retrieval, and management. Databases are an organized collection of structured information or data, typically stored electronically in a computer system. Modern databases are managed by database management systems such as Oracle, MySQL, PostgreSQL, and Microsoft SQL Server, which provides tools for data storage, retrieval, and management. Some core components of database are things like tables. They store data in rows and columns. Schemas define the structure and relationships among data. Indexes improve query speed by optimizing how data is located. Transactions ensure ensure ACID properties, and queries written in SQL or similar language to retrieve or manipulate data. Now I'll inform you guys about why databases are so important. Databases provide a structured and centralized way to store data so it can be easily accessed, managed, and updated. Without databases, data would be scattered across files, spreadsheets, or systems, making it very difficult to keep consistent or retrieve quickly. In a real world example, banking systems use a database to store account balances, customer details, and transaction histories all in one coherent place. Database enforces rules like constraints, relationships, and transactions that keep data accurate, consistent, and reliable. A banking system uses a database to store account balances, customer details, and transactional histories all in one coherent place. For example, in an e-commerce site, a database can instantly return all available products under laptops less than $1,000 from a huge catalog. Databases allow multiple users or applications to access and manipulate the same data safely and coherently. This is crucial for enterprise systems where hundreds of thousands of users, like employees and financial sales, might be interacting with data simultaneously. Now we're going to look at database from a security standpoint. Databases hold an organization's most sensitive information, like customer data, employee records, business secrets, operational data, and much more. Because of this, databases are prime targets for cyber attacks and insider threats. A breach doesn't just risk data theft, it can destroy reputation, violate regulations, and lead to costly penalties like GDPR and HIPAA violations. Now I'm going to get into our database system, PostgreSQL. A little bit of overview. PostgreSQL is an open source object relational database management system known for its robustness, performance, and advanced features. It's developed and maintained by a global community released under the PostgreSQL license. Some key features of PostgreSQL are ACID compliance, which ensures reliable transactions, advanced SQL support that supports subqueries, Windows function, common table expressions, and partial indexes. Extensively, which allows users to define their own data types, operators, and functions. Multi-view concurrency controls help handle concurrent transactions efficiently without conflicts. Replication supports streaming replication logical replication, and point-in-time recovery. The JSON supports enables NoSQL-like operations on structured and semi-structured data. And finally, its structured features include role-based authentication, role-level security, and data encryption. Give you a little bit more about the overview of PostgreSQL. PostgreSQL is a general-purpose database used across a wide variety of industries. It is commonly used for web and mobile applications. It serves as the backend database for web frameworks like Django, Ruby on Rails, Flask, and Spring Boot, and commonly used with APIs and microservices architectures. Another great task is able to do is data storage and analytics by handling large data sets via parsing tables, parallel query execution, and indexing. It integrates with BI tools such as Tableau, Power BI, and DataBase. Its ecosystem consists itself with tools like PGA Admin, which is admin and a development tool, PSQL, which is a command line interface from direct SQL integration, and extensions like PostGIFs, Citrus, Timescale DB, and PG routing. So I'm going to give you guys a hardening example. For network security and access control, you would first restrict listening address. It is recommended that you set listening address to localhost if the application is on the same server to specific IP addresses. You need to connect avoid listening address. You do this because it prevents PostgreSQL from listening on all available network inferences, reducing its attack surface. You configure PBA-HBA.com for strict access. It is recommended that the files control client authentication be very specific. Use host or host SEL for encrypted connection lines. Specify the exact database user and allow IP addresses ranges. Avoid any IP for or all for users of databases. Order matters. Rules are processed sequentially. Put specific rules before more general ones. And on the right, I have an example. You do text. You do hashtag allow connections for app users to AppDB from a specific ID range requiring scram SHA-256, and you do host SSL app DB app underscore user IP and scram SHA-256, and you deny all other connections by default. And now are two more hardening examples for PostgreSQL. To enforce strong authentication methods, it's recommended that you do INPG HBA.com configured preferred robust methods like scram SHA-256, recommended modern secure password-based authentication, cert for client certificate authentication very strong. For enterprise integration, use Carabo's Active Directory, and for local connections where OS level user mapping is secure. To encrypt data in transit for the SSL or TSL, it's recommended that you set SSL on a PostgreSQL.configure, configure SSL cert file, SSL key file, and optionally SSL CA file with verified certificates. Require SSL connections in PG HBA.configure using host SSL for remote connections. Configure client applications to always use SSL. Alright, now we're going to look at PostgreSQL from a security standpoint. PostgreSQL is one of the most secure and reliable open source relation database systems available. From a security standpoint, PostgreSQL employs a layered approach often described as defense in depth, which means security is enforced at multiple levels: network access, authentication, data authorization, and storage protection. Each layer builds up builds upon the others, ensuring that even if one control is compromised, additional safeguards remain in place. PostgreSQL offers extensive flexibility and strong cryptographic standards. Administrators can define who's allowed to connect and how they authenticate using the PG HBA configuration file. It supports modern secure authentication methods such as SCRAM-SHA-256, client certificate authentication, and Kerberos or Active Directory integration. Now I'm going to compare PostgreSQL with another database called MongoDB. First, I'm going to talk about Postgre. Its data is stored in structured tables with fixed columns, rows, and relationships. The schema must be defined before data insertion changes require alternate table definitions. Its powers standardized language for complex queries, joins, and aggregations. It ensures transaction ultimacy, consistency, isolation, and durability for all operations. Now for the MongoDB database. Its data is stored in flexible JSON-like documents with collections and it has no fixed schema. Its schemaless documents in the same collection can have different fields and structures. JSON-like queries, syntax, rich set of operators, and aggregation framework. Guarantees ACID properties for single document operations. Multi-document transactions exist but are more complex and have performance overhead. Here are some of my amazing sources that I use. And I would like to thank all of you guys for taking the time to watch this presentation. And that concludes the end of this database presentation.